Inkling's not a model, it's a manifesto. Because hidden inside Thinking Machines' Inkling model launch is the 13-point blueprint revealing exactly how they think the next AI race will be won. But number 1, stop chasing leaderboards. They openly admit Inkling is not the strongest overall model, because their goal isn't to win the existing leaderboards. They acknowledge that different users need models that can adapt to very different workflows, not just to excel on benchmarks. Their argument is simple. Robust agents don't come from memorizing one framework, they come from adapting to many. They explicitly position Inkling as a customization base. The model is meant to be the starting point. But number 2, native multimodality is mandatory. They first convert audio into semantic tokens, then train alongside the text, image, and video inside one shared reasoning model. Their bet is that future AI shouldn't switch between separate speech and language systems. It should reason over every modality using the same internal representation. But number 3, chatbots are just an intermediate interface for now. Inkling is a background reasoning model designed to power interaction models. Thinking Machines calls chatbots an intermediate interface, but everyday humans continuously take in audio, video, text, and think, respond, and act in real time. They're focused on making AI models interactive and to let people collaborate with AI the way we naturally collaborate with each other. But number 4, the smartest model isn't the one that thinks the longest, it's the one that knows when not to think. Reasoning itself should become a controllable resource that the model learns to allocate. They evaluate models across an effort performance curve, rather than reporting only a single benchmark number. Thinking Machines is asking, how much additional intelligence do we gain for every additional unit of compute? Because more reasoning improves difficult tasks, increases latency, increases token usage, and less reasoning reduces cost, improves speed, but may hurt complex tasks. The industry often treats this as a user-controlled parameter. Thinking Machines is betting the model itself should learn this trade-off. Bet number 5, calibration over confidence. Normal reward functions can create a failure mode. The model learns to always give the answer. However, they believe that proper scoring rules reward the model to express uncertainty accurately. The model gets rewarded for saying, hey, I'm highly confident because the evidence is strong, or hey, I'm uncertain because evidence is weak, or that multiple outcomes are possible. This distinction matters because real-world AI systems operate in environments where information is incomplete, mistakes are expensive, and users need to know when to verify outputs. But number 6, prediction is a deeper test of intelligence. Thinking Machines believes that intelligence is sometimes about making decisions when the answer is unknown. So forecasting forces a model to estimate uncertainty, combine evidence, calibrate confidence, and reason about possible futures. When the model has to search supporting information from its own knowledge base, reason over incomplete information, estimate uncertainty, and update beliefs, that makes it much closer to a real-world decision-making. But number 7, reinforcement learning is where intelligence is built. This might be the biggest bet in the entire launch. Everyone talks about pre-training, but it's evident that Thinking Machines is talking about post-training. They made over 30 million RL rollouts. Lots of synthetic environments, human environments, and their message is clear. Reinforcement learning shapes intelligence. Bet number 8, RL scaling is far from over. A lot of researchers believe reinforcement learning is hitting diminishing returns, but Thinking Machines is making the opposite argument. They report reasoning improved almost log linearly across 30 million rollouts. Their conclusion? That RL scaling curve is still alive. Bet number 9, agents should be trained, not prompted. Many labs rely on scaling general capabilities and external agent scaffolding, while Thinking Machines is making a bet that agentic capabilities should be part of the model's training distribution itself. Thinking Machines argues that agents require dedicated training environments, not just prompting, and that generalization requires exposure to diverse tools and interfaces, and that the model itself can participate in the improvement loop. Bet number 10, the parameter race is becoming a training efficiency race. Thinking Machines said that Inkling Small at 12 billion parameters matches or exceeds its larger sibling on many benchmarks because of improvements we made to the pre-training data and the recipe for the smaller model. The data determines how the model learns. So better examples, better mixtures, less noise, and more coverage. The recipe determines how efficiently it learns, how data is fed, how weights are updated, how training scales, how the architecture converts compute into intelligence. Bet number 11. Long context is not solved by scaling. Long context requires redesigning the transformer's core components. They explicitly moved away from rotary positional embeddings. They found relatively positioned embeddings performed better and extrapolated better to longer sequences. They combined sliding window and global attention layers, and they added short convolutions into the attention and residual pathways. But number 12, safety has to survive customization. Open weight models are built to be changed, fine-tuned, adapted, and modified, so alignment cannot only work on just the original model. Thinking Machines is studying safety after fine-tuning, because if safety disappears after customization, it was never truly robust. And bet number 13, this wasn't just a model launch, it was a roadmap. Thinking Machines are building models that adapt to different users, reason natively across every modality, have audio, image, and textual meaning interlinked, know how much compute a problem deserves, understand their own uncertainty. Its architecture must evolve with scaling. RL creates deeper capabilities, show continued gains from more RL, can operate inside changing environments, operate based on a performance per effort framework, extract the most intelligence out of every parameter, and safety must survive customization. Inkling isn't just a new model, it revealed itself as a technical roadmap for where Thinking Machines believes the industry is heading.